New AI breakthrough can finally detect parasitic worm infections. This is by Trirupa Chakraborty and colleagues from the conversation. Blood samples of patients infected with a parasitic worm that causes schistosomiasis contain hidden information that marks different stages of the disease, and this is the head of a male vampire worm with the little female poking out from its back groove at the bottom of the image, as we can see there. Isn't that strange? In our recently published research, they said our team used machine learning to uncover that hidden information and improve early detection and diagnosis of infection. The parasite that causes schistosomiasis completes its life cycle in two hosts, first in snails and then in mammals such as people, dogs, and mice. Freshwater worm eggs enter human hosts through the skin and circulate throughout the body, damaging multiple organs, including the liver, intestine, bladder, and urethra. When these larvae reach blood vessels connecting the intestines to the liver, they mature into adult worms. They then release eggs that are excreted when the affected person defecates, continuing the transmission cycle. Since diagnosis currently relies on detecting eggs in feces, doctors usually miss the early stages of infection. By the time eggs are detected, patients have already reached an advanced stage of the disease. Because diagnosis rates are poor, public health officials typically mass administer the drug praziquantel to populations in affected regions. However, praziquantel cannot clear juvenile worms in early stages of infection, nor can it prevent reinfection. Our study provides a clear path forward to improving early detection and diagnosis by identifying the hidden information in blood that signals active early stage infection. Your body responds to a schistosomiasis infection by mounting an immune response involving several types of immune cells, as well as antibodies specifically targeting molecules secreted by or present on the worm and eggs. Our study introduces two ways to screen for certain characteristics of antibodies that signal early infection. The first is an assay that captures a qualitative profile of immune response, including various classes of antibodies and characteristics that dictate how they communicate with other immune cells. This allows us to identify specific facets of the immune response that distinguish uninfected patients from patients with early and late stage disease. And second, we develop a new machine learning approach that analyzes antibodies to identify latent characteristics of the immune response linked to disease stage and severity. We train the model on immune profile data from infected and uninfected patients and tested the model on data that was not used for training and data from a different geographical location. We identified not only biomarkers for the disease but also the potential mechanism that underlies infection. Why it matters? Schistosomiasis is a neglected tropical disease that affects over 200 million people worldwide, causing 280,000 deaths annually. Early diagnosis can improve treatment effectiveness and prevent severe disease. In addition, unlike many machine learning methods that are black boxes, our approach is also interpretable. This means it can provide insight into why and how the disease develops beyond simply identifying markers of disease, guiding future strategies for early diagnosis and treatment. What still is not known? The schistosomiasis infection signatures we identified remain stable across two geographic regions across two continents. Future research could explore how well these biomarkers apply to additional populations. Further, our work identifies a potential mechanism behind disease progression. We found that a particular immune response against a specific protein on the surface of the worm signals an intermediate stage of infection. Understanding how the immune system responds to this understudied antigen could improve diagnosis and treatment. And what's next? Besides improving our understanding of how the immune system responds to different stages of infection, Our findings identify key antigens that could pave the way for designing cost-effective and efficient approaches to diagnosis and treatments. Our next steps will include actual deploying these strategies in the field for early detection and management of disease. The research brief is a short take about interesting academic work, and this is from the conversation here under Creative Commons by Trirupa Chakraborty, PhD candidate in Integrative Systems Biology, University of Pittsburgh, and colleagues on Science Alert. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.